don't think of it as, don't think of the other three in terms of inverses, because they're not. Okay? Those other threes are not the inverse. So the cosecant is not the inverse of the sine. Okay? That's a different thing. The reason why is because, remember, the sine is this operation I'm doing to the angle theta. Okay? So I got to do, so if I want to undo it, I have to do the opposite operation. The cosecant is not the opposite operation. It's a different operation altogether. Okay? So when you're thinking of these things, they do flip these fractions, but they're not the inverse. Okay? So the flip, so the cosecant is the flip of the sine, which would be what? 17 over 8. Okay? The secant is the flip of the cosine, which is 17 over 15. And the last one, the cotangent, is the flip of the tangent, which would be 15 over 8. Okay? Good. All right? And so you want to try to remember these things as such, okay? Any questions there?
Sure.
All right, good. So, that's how this works. By the way, there are lots of little relationships between sine, cosine, tangent, cosecant, secant, cotangent. Okay? And a lot of times these little relationships, a lot of which you'll have to learn, get special, they're grouped together and they're given special names. The first relationship that I'm going to introduce to you based off of this right here are what's known as the reciprocal identities. I spell reciprocal wrong, I always do. Okay? And they tell you the relationship between all these. So the sine of theta, for example, can be written as 1 over the cosecant of theta. Likewise, the cosecant of theta can be equal to 1 over the sine of theta. And when you think about it, isn't that exactly what's going on there? Okay? When you write something as 1 over, especially when you're doing it as a fraction, all you're really doing is turning the fraction upside down. And that's exactly the relationships here between these things. Just turn them upside down. So, how can I rewrite the cosine of theta? I can write that as
1 over the
cosecant.
1 over not cosecant, but just secant.
Secant.
Yes, that's one of those things. You always, when people are learning this for the first time, they always want to pair cosine and cosecant because they both begin with co.
Yeah, that is.
The way to remember it actually is, if it starts with a co, it's always paired with something that doesn't have the co in front of it. Okay? Because think of it as like, I think the secant, and then the one that goes with the secant would be the
co.
Yeah, the co would be the opposite of it.
Pilot, co-pilot.
Yeah. Okay? Think of it that way. And in fact, when you guys take calculus next year, and you're doing more of these things, that relationship, the thing that's co, actually comes out to is actually even more pronounced, because if I basically, like, if I do a process like if I take the derivative of the sine, it's equal to the cosine, okay? But if I take the derivative of the cosine, it's equal to the negative of the sine. And so if you do like derivatives of anything with a co in front, it's always negative. That sort of relationship. It's kind of this weird, there are lots of like weird little things, but if it starts with a co, it's always paired with something that's not starting with a co. So tangent, 1 over cotangent. Okay, so cotangent is 1 over tangent of theta. And these can help you a lot when doing things, okay? Especially when we look at things involving the unit circle and we have to calculate things out. For example, okay, we had problems 17 through 28 from the homework, had you just basically write out, relationships between or unit circle values with things like that. It was basically just getting you used to the unit circle. But if I came through and wrote something like, what is the, using the unit circle, tell me what the secant pi over 4 is equal to? Well, the secant, if you remember the definition of it, or not the definition, but its basic ratio, is that the secant was equal to 1 over x, right?
That's because it would be cosine, right?
Because it would be the flip of the cosine. The cosine is just equal to x, so the secant is 1 over x. So instead of necessarily trying to, if I can remember that the secant is just 1 over the cosine, I can just figure out instead what the cosine is, and just put a 1 over it. The cosine pi over 4 is root 2 over 2. Okay? We could look that up on the unit circle, but that's what it is. So the secant of pi over 4 must be then 1 over root 2 over 2. Okay? Like so. And I don't mind if on a test or a quiz you leave the answer like that. The issue though is that a lot of times in the book they're going to do this, on standardized tests they're going to do this, and when I write problems for you all to do, for you all to do, I'm going to do this as well, is that we always will simplify what this fraction is. We won't leave it as kind of literature and tests and stuff. Don't leave it like this. They simplify it. So simplifying it out, that would make this 2 over root 2. But can we leave things as 2 over root 2? No, we're not supposed to. So we clean this up further to be 2 root 2 over 2. And what's going to happen to those 2's? They cancel. So the secant of pi over 4 is actually just equal to root 2. Okay? When you fully work it all out. Okay? But note, the only way I can figure that out though, okay, is from just recognizing the beginning right here, that this thing was equal to the flip of the cosine. So this is really 1 over the cosine of theta, which would be 1 over x, which is 1 over root 2 over 2. Okay. Shouldn't write theta. We know it's pi over 4. Excuse me. There we go. Okay. And so that is, again, how these relationships here help you solve something like that there.
I don't see how that worked out there. It was, you multiplied 1 over root 2 over 2 by 2 over root 2. So when the denominator...
Didn't multiply. It's equal to 2 over root 2.
Okay.
Because remember, if I have an extended fraction like this, okay, the denominator just pops up and just flips.
Okay.
When you put 1 over something, you just, when you put 1 over a fraction, you're just saying flip the fraction.
Okay.
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 Which is what I did there. Then how I got from 2 over root 2 to the next step was I rationalized it. You're not supposed to have square roots in the denominator.
Right.
So I multiply it by root 2 over root 2, basically. And that's how I ended up 2 root 2 over 2. And then things cancel there, leave you just root 2. Okay. It's better?
Yes, sir. Thank you.
Okay. So, relationships like that are kind of what you want to work with these things. Okay. Any questions? By the way, something else we saw from these things is if we're given what an identity is equal to, okay, or if what one of these things is equal to, we can reverse it back to figure out what the angle should be. Okay. Now there may be multiple answers for that angle, but we can certainly do so. Let me give you an example of that. Okay. Suppose I told you that the sine of theta was equal to root 3 over 2. And I wanted to know what theta gave me that. Okay? Well, looking at the unit circle, okay? Oops.
15.
Remember, this thing works as a, again, we want to think of it as like a gauge, a speedometer, and where the needle's pointing to, we take the reading there. This case, we've got what the reading is, we just need to know where the needle's pointing, okay? So, if I wrote all this out, oops, no. Oh, come on.
So when you see sine theta and then whatever that number there, you're thinking about the y coordinate, right? 'Cause
This is the y coordinate, and you're trying to figure out what locations, where the needle points to give me that y. Yep. So if I wrote this out here, I can see, oh wait, right there is where the y coordinate's root 3 over 2, right?
60, right?
Which happens at 60 degrees or
pi
over 3, okay? So I can say then that theta is equal to 60 degrees or pi over 3 radians. Now, the issue though is that the only location where that's going to happen?
No.
Won't it also have the same values over here? This is where they also have the same y values, right?
Reciprocal, no. Just
Not reciprocal,
negative.
it's just, it just ends up that there can be two angles that give us this answer, okay? So over here, when it's minus 1/2, the y coordinate's still root 3 over 2, okay? And that happens at 120 degrees or 2 pi over 3. So theta could also be equal to those as well, okay? And in all honesty, there would be, in all honesty, unless you're specifically given a domain to look at, there's no way to tell. You just end up with two answers, okay? Which can happen. I mean, we've seen that happen before with quadratic equations, right? When you have two zeros, that's two solutions. Well, here you're going to have two angles that give you the same answer, so you have two solutions, okay? That's a possibility, okay? Without any other domain restriction, I would just have to assume there's multiple answers. Now I could say, only give me the answer when theta is greater than pi over 2, in which case, only this one would work. I could say, give me the answer between negative pi over 2 and positive pi over 2. In that case, only this answer works, okay? No. Whiteboard's kicking my butt this morning. Okay, smart board. Okay, but if it's just currently written straight out, that's what you're going to end up with. Okay. Any other questions about that? Yeah.
So this is the without the calculator.
Yep. All without the calculator. By the way,
if we had the calculator.
If you had the calculator, you can do this. Okay, with the calculator.
Arc sine.
Okay. You use something called the arc sine. Okay. And the arc sine is the proper inverse of the sine, okay? Because what the arc sine does is it undoes the operation of the sine, okay? Remember, the sine can be treated like an operation. The sine is something I do to an angle to get an answer, okay? So it's the same way as like I'm adding two numbers, or I'm dividing something, or I'm doing an absolute value, or something like that, okay? So if you're trying to do the inverse of it, you have to do the operation that undoes it, basically. It's the opposite of it. That's what the arc sine is, okay? So with a calculator, I could write, if I had the sine of theta equals root 3 over 2, I could do the arc sine of both sides. Okay, and that would give me my answer. Now, where's the arc sine on a calculator? It's actually the second function. Okay? If you look at your calculator, okay, it's got above the button sine, cosine, and tangent. It says sine -1, cosine -1, tangent -1. Show you right there. Sine, cosine, tangent, the -1's above it.
There you
go.
Play.
Basically, that sine -1 means inverse sine, right? When you see a -1, it tells you that it's inverse. Well, this is the inverse of the sine, it's the arc sine. Whatever you do, this is super important. Everyone, people, there's guarantee you somebody's going to make this mistake at some point. The cosecant is not the arc sine. So this button here the sine minus 1, that's not the cosecant button. In fact, there is no cosecant button, okay, on your calculator. Okay? If you wanted to do the cosecant in the calculator, you have to use this identity right there. Okay? So if I wanted to calculate what the cosecant was, okay, we'll say if I wanted to calculate the cosecant of pi over 3, I would have to enter it in the calculator as 1 over the sine of pi over 3. Okay? And it would give me my answer.
So it's 1 over sine.
Yeah. It's not sine negative 1 of pi over 3. That would be a very terrible looking answer, usually. Okay? Note 2, if I use the calculator to get my answer, to calculate this out, the arc side, because of the way it works, it will only give you values between negative pi over 2 and pi over 2. Okay? We'll explain why that's the case later when we formally go over inverse trigonometric functions. Okay? But it's only going to give you one of the two answers in this case. So you would still have to, you would get that answer and be like, okay, that's one answer. Look at my unit circle and say, okay, where else? Where is the opposite, basically, at that point? Okay? And there's really just no way around it. It's just the way it works. Okay? Any questions? Tasty coffee this morning. Okay.
You gotta get a Diet Coke. Diet Coke in.
Diet Coke. I don't have Diet Cokes, I have Diet Dr. Peppers.
Got you.
All right. We've got just about 10 minutes left of class. So those of you who have not taken the quiz, the unit circle quiz, stay put. Everyone else, you are dismissed. Okay? Oh dear.